Okay guys, the GC analysis for the distillation lab is now available on eCampus. Let me show you. If you click on experiments and you go to the simple versus fractional distillation, you will see group A GC scans. Then the lab manager ran some standards. I will use those standards to explain some things to you in a moment. These are not your results. I'll talk about these standards in a moment. The most important thing about the standards is the calibration curves right here. I will also talk about the calibration curve in a moment. Now, let us go back. You will see your chromatograms, the results of the GC analysis of the distillation you performed. When you click on that, based on, you all know your initials and you know your unknown numbers, and whether you performed simple or fractional distillation, and the lab manager published the GC analysis for each of the fractions you collected. So for example, this is a student that has an initial II with an unknown number 1. The student performed simple distillation and fraction number 1, which would be in flask number 1 when this student performed the distillation. This would be the chromatogram for fraction number 2 for the same student II, unknown number 1. This is for fraction number 3. Well, this student only had 3 fractions. And then we have another student with initial GG, also working on unknown number 1, which means GG and II are actually partners. This is fraction number 1 for GG, and so on. If you scroll down, you should be able to find your own chromatograms. Now, let me explain how to analyze these chromatograms. I will use the standards that I told you about initially. I will use them as examples. This is standard number 1. These standards were used to generate a calibration curve, which would allow you to calculate the percentage of each of the components in your sample after the GC. Let us take a look at this one. In this chromatogram, the sample name is MPB-1. That is just one of the standards. If you look at it carefully, you will see 3 peaks. Number 1, number 2, number 3. And if you look right below the chromatogram, you will see the peak table. The very first thing I want you to note is the retention time. The retention time can be used to know the identity of each component. When the lab manager injected MPB-1 into the gas chromatography machine, he was expecting 3 peaks because he injected a mixture of methyl acetate, propyl acetate, and butyl acetate. And that is why we have 3 peaks. The most important part is this. Each component has a peculiar retention time. For methyl acetate, the retention time, that is the time from the time you injected methyl acetate into the machine to the time it is detected, to the time it was detected by the detector, was 1.261 seconds, and so on. Each component would behave in a peculiar way, and from that you would be able to identify your unknown. Let us take a look at standard number 2. Again, the lab manager injected methyl acetate, propyl acetate, and butyl acetate, which is why he's using the acronym MPB. And if you look at the retention times and you compare to the retention times in the first standard, you will see that they are within the same ballpark. 1.261 in the first standard for methyl acetate, 1.29 for methyl acetate in the second standard, and in the third standard, 1.31. So within the same ballpark. The same thing for propyl acetate, 1.856 for the third standard, 1.837 for the second standard, and 1.839 for the first standard. In a nutshell, you can use the retention times to know the identity of the component giving you the peak. The third thing to note about the chromatogram would be the areas under the peak. These areas will enable you to calculate the percentage of each component. And how will you be able to do that? You will be able to do that by using the calibration curve. Let me explain how to use the calibration curves to determine the percentage of each component in a mixture. Let us take a look at standard number 1, MPB-1. On this chromatogram, we have 3 peaks, which would correspond to 3 components in the mixture. And these are the 3 components: methyl acetate, N-propyl acetate, and N-butyl acetate. Let me use methyl acetate as an example. If you look at the retention time, it is 1.261. So I know that this peak is the peak for methyl acetate. The question is, what percentage of methyl acetate was in the mixture that gave me this peak? To determine that, I will have to look at the area under the peak, which the machine already calculated for us. The area under the peak is 2016642. I will then use that area on the calibration curve provided by the lab manager. If you look carefully, you will see that 3 calibration curves are actually provided. One is for methyl acetate, if you look down here. Another one is for N-propyl acetate. And the third one is for N-butyl acetate. Let us focus on methyl acetate. This is a linear graph. The vertical axis is the area under each curve in the chromatogram. The horizontal axis is the concentration of methyl acetate that corresponds to the area under the peak. This is the equation of the straight line. Y equals to 30000x minus 37970. Now remember, x represents the percentage of each component and y is the area. I want to find the percentage of methyl acetate in standard number 1 injected into GC. Since I want to find x, I will rearrange the linear equation provided by the Excel to look like this. Now, for methyl acetate, I will plug the area into the position of y. The area that I got was 2016642. So this will end up being 2016642 plus 37970 divided by 30,000. Whatever you get would be the area of methyl acetate in standard number 1. When I did it, I got 68.5%. So, percentage of methyl acetate in this mixture will be 68.5%. Let us take a look at N-propyl acetate. This is the peak for N-propyl acetate. I want to know the percentage of N-propyl acetate in the standard, which means I need to look at the area under the peak as provided by the computer. In this case, it is 253460. Then I will go to the calibration curve. For propyl acetate, I already rearranged the equation for you. I then will plug in the area in the position of y to find the percentage of N-propyl acetate. If you do that, you should get that the percent N-propyl acetate in standard number 1 would be 9.3%. And lastly, on this chromatogram, let us determine the percentage of N-butyl acetate from the peak. The area under the peak for N-butyl acetate is 663502. I will plug that area into the equation for N-butyl acetate as obtained from the calibration curve. So you plug the area in the position of y, and if you do that, you should find that the percent N-butyl acetate would be equal to approximately 25.7%. When you add up this, it's not going to be exactly 100% because this has some errors around plus or minus 5%. But this is how you would determine the area under each of the peaks you get from your distillation. So I just did MB1 standard. You can also practice with MB2 standard for yourself. The lab manager uploaded all the chromatograms. We also have MB3 standard, and the lab manager also uploaded a blank which only contains the solvent used to rinse the syringe used in the GC. And as he expected, he only got one peak. So if in your distillation the GC gave you only one peak, that means you have 100% of the component that gave you that peak. If you run into any difficulty, get in touch with me.